All right. Thanks so much. So my name's Chris from NYC Planning Labs. I'm joined by Andy and Matt, who are up over here in the front. And we're going to tell you a little bit about what we do at the Department of City Planning. We're a development team there. We'll start with the problem statement. Government technology projects take a long time, cost a lot of money, and can be lacking in user experience. And I think, in general, we don't have very high expectations of what is possible with technology in government. We hear horror stories about vendor lock-in and just sort of really clunky relationships with technology providers that are better at winning contracts than they are at actually building technology. And then at the same time, we're sort of living in this revolution of open source software, sort of democratization of access to tools, and sort of new ways of thinking about user-centered design and how we can make the best outcomes. So the response to this is lean development teams that can prototype quickly, use free, cheap, and open source tools, and I mean cheap in the financial sense, not in the sense of value, and then start with design thinking as a sort of critical part of the process. So enter NYC Planning Labs. We're a small team at the Department of City Planning that embraces these values, and we've been around since last summer, so we're coming up on a year. But we embrace open technology, agile methodologies, and human-centered design in government. And we are here to sort of raise your expectations. We're going to build awesome software. We're going to do it in a very sustainable way. And we're going to basically help planners do their jobs and help New York City citizens understand their city better. So our core values, we're open by default. So everything we do is, all of our code is on GitHub. We're extremely open about what we're going to be working on next and how you can get involved, even if you're not a developer, inside of our agency. We build with and not for, and I mean that in the truest sense of the word. We'll actually train a lot of our customers who are other divisions at city planning to participate in the Git workflow. So they know how to make issues, they know how to actually go in and make small changes to text and change tooltips, and they may not be able to do actual programming or write JavaScript, but they can actually still help, and it's very empowering to our customers. We ship early and ship often, and this is sort of just talking about the culture of trying things out, which is not something government's used to. Government is extremely risk averse. We like to have sort of top-down, monolithic, and draconian technology policy at times. And we're here to represent the culture of open source, the culture of tinkering, experimentation. Fail early, fail fast is another way to look at it. But basically, we ship. We ship a lot. We'll dream up something in the morning, and we'll ship it in the afternoon. And then documentation dissemination. And this is sort of the last part of the puzzle. But if nobody knows that you're doing this great work, it's not going to benefit as many people. So we write blog posts, we're on Twitter, and we're constantly sort of engaged with the community. And this is part of that as well. We want you to understand that there can be great work happening in government, and you can benefit from it as well. So we like to say that how we build is as important as what we build. So the products are the products, the data are the data, but how we build is what's going to make these sustainable. It's going to make sure that this product that we built that's awesome doesn't come with a hefty price tag or a vendor relationship that's going to mean that we're stuck with it or that we have trouble making changes in the future. So kind of everything that we do and how we operate supports this model that how is more important than, or how is just as important as what. And then open source software. So the name of the talk is talking about the spatial stack. So that's what we're going to get into right now. You'll see CARTO's up on the board. It's a very important part of the way we do mapping infrastructure. And just about everything that we do in everything that we do at city planning is going to involve some kind of map. Maps are sort of the language of how planning gets done and how the built environment gets communicated. So you also see up there Ember. You see PostGIS. You see just JavaScript in general, which we use lots of JavaScript frameworks and libraries. And this is our team. So it's 3 of us. We're very scrappy and been around for about a year, sort of proving our worth. And I think we're hoping to grow soon and sort of make this a little more of a little more sustainable and a little more of a built-in part of government, a little more normal. So we like to use this quote: "Demos, not memos." We demo every Friday, so we run on usually a 1-week sprint cycle when we're working with a customer. At this point, we want to actually show you some of the tools we built. So I'm going to bring up my colleagues. They're going to demo our tools, and then we'll get into sort of what the stack is, what the different parts are. We're even going to do some live coding to show you how we operate. So I'm going to invite Andy Cochran up to the stage, who's our designer, and he'll show off one of our tools. Thanks, Andy.
There we are. I'm Andy. I'm the designer with Planning Labs, and I'm going to show you guys. This is our zoning and land use map. We call it ZOLA, but don't confuse it with the wedding registry website. This has actually been around quite a while longer. This is kind of like DCP's, city planning's like flagship product. So you know, at this like macro level, you can see. Well, first let me tell you the primary responsibility of DCP is to regulate the zoning and land use throughout the city. So at this macro level, you can see where throughout the city there are zones for commercial districts or manufacturing, residential, parks, and things like that. So you can also, as you zoom in, you'll see through our, because of we're using vector tiles, we get this nice smooth scrolling, and you'll notice that things start to fade in and change. So at this level, the stops on the subway fade in, and you get even closer, and you can see labels and eventually you even see like the names of the subway stops and things like that. You zoom down to like a really close level, and you'll see that actual block and lots start to fade in. So these are the parcels throughout the city. So at this point, you can actually you can click around and get information about a particular place that you're concerned with. But the way most people would approach this, they would come in here with something in mind. They have an address, or like a builder or a planner or a landowner would have an address that they're concerned about. So the first thing they do is search, and this is what our analytics tells us. We built a search feature. You can just not an exclamation mark, a 1. So 120 Broadway is where DCP's office is. I can just type in 120 Bro, and you can see I get these nice type-ahead search results. This actually comes from another service that we built, which is called GeoSearch. GeoSearch is it's a custom instance of the Peleus geocoder from our friends at Mapsin. I know there's some of you here at this event. Thanks for open source software. Thanks to that, we can do things like use this geocoder. So that's actually using authoritative data from the city to create records of addresses throughout the city. So you can search for any actual address or any possible address. It's just using ranges. So it's actually really powerful to find anything you need in the city. A building that exists or doesn't exist or could exist. It's great. So then you can just click to go to that thing. Where you have other options for finding things. You can just click on the lot, or a lot of people are out in the field. This actually works on mobile devices, so it's responsive. If you're out in the field, you can actually just click this locate button, and let's hope this works on the Wi-Fi. Give it a second, and it takes you right here. Here's where we are. This is the building we're in right now. So we can just click on that and get some information. So you'll see it brings up information from Pluto, which is open data. It tells us the general zoning, so you can see that this is a C4-3. No one knows what that means, maybe. So you can click that, and it'll take you to DCP's website to find out more information about that. It also tells us this is in a transit zone and some other details. We show you that the information that's for the built environment on that on this lot. We can see like the land use that's happening there, and the lot area, and all the details like that. We also show you a little bit of like neighborhood information that's in which community district it's in, which council district it's in, things like that. But you can also see like what does this thing look like in real space. Of course, this is coming from the highway, so maybe it's not the best view, but you can actually see what that looks like in real space. So we have a bunch of other layers here that you can turn on. Actually, as you get down to the tax lot level, you can actually turn on the land use colors and see like what's happening at like things clustered together. And you can see like what's actually happening at this place, whether they're multifamily or single family, mixed use, things like that. There are other like supporting layers that you can turn on. You can see like is this lot I'm concerned with, is it in an area that requires mandatory inclusionary housing, or something like is it in the flood zone? We could turn on the flood zone layer and say and see, like, is this slot in the flood zone? It's great. We built this in about 6-7 weeks or so. Launched it kind of internally. We got some feedback. We spent a few more weeks on it, but we're continuing to improve it constantly. The biggest piece of feedback that we got from folks was that people are not just concerned with one lot. They want to view quite a few lots. Like if I'm interested in a lot of things that are happening on this street, there's no way to view all this information at once. The way we've actually engineered this, you pull up the information, for instance, for 47 Catherine Street, and the URL changes up here. It's giving you a lot, or the borough, the block, and the lot. So there's actually a unique permalink for every single lot in the city, which makes it really easy for planners and builders to send each other information. They can share this URL, and what's actually really cool is as I turn on these layers, they're also in the query parameters in the URL. So if I send someone a link, I can be assured that they're seeing exactly what I'm seeing, which is cool. But back to people who are concerned with more than one thing. So we added this ability to any lot you're looking at, you can check this bookmark in the top right corner, and you'll see it changes its style on the map. If I can go through and say I'm actually concerned with this group of things here, and then now I have them visualized on the map. These are my collection of things that I'm looking at. We have this Save tab here, where you can actually look at the list of things that you've accumulated in building your study area, and from this point you have the opportunity to download that data as a shapefile or a CSV, which is really cool. There's a few other little bells and whistles, like I can turn on 3D buildings and things like that. Let's turn on these land use colors. Now this is a new feature that we've just introduced, is print. I've heard a lot of people yesterday talking about how everyone asks to print your web maps, and it's us as map makers, we're like, why would you want to print it? You have this nice slippy version where you can zoom around, but people love to print maps, so we've added this new feature. See a little print icon here. Thanks to the way that that Mapbox.gl works, the map is actually contained in one style object, so we can actually take that object and I hit print, and I'd send this object to this print service that we've built. This print service can be sent any object that's like a Mapbox.gl object or something. That you bring this in, and then you have the opportunity to see exactly what this is going to look like when you print it. So you print that. That's exactly what you're going to get. It's great, and you actually have the opportunity to edit that and say, this is my study area. Give it a subtitle if you want. Let's say I don't want that on there. And it shows a source, things like that. So we're truly trying to make printing maps really easy. So and you can actually even once you've got there, maybe it wasn't centered right, you can go ahead and fix that. Tilt it, however you want to do it. Pretty cool. So that's Zola. And now I'm going to bring up Matt Gardner. He's going to show you guys another project.
Great. Well, thank you, Andy. So I'm going to demo an app we have called Population Factfinder. So who here has ever had a question about their neighborhood? Oh, okay, great. Perfect audience. Lots of people with questions. I love that. All right, so first off, I'm going to start off with where we are right now. So we're obviously in Williamsburg. And suppose I want to maybe refine my study area a little bit and explode that. So what this tool is going to do for me is it's going to allow me to define the study area. I've started off with Williamsburg, but in these buttons here, I'm able to sort of move up and down the different summary levels for the census data. So if I want to refine it a little more, I can do that, and I can say, all right, well, maybe that's my study area. Maybe I want to clear it and draw a polygon instead. So I can actually start drawing a study area and get some polygons, but suppose maybe I would like to do a radius. So I can say, oh, okay, let's do almost a quarter mile and get something like this. So this allows me to really kind of hone in on my study area. And once I've defined it, I can generate our profile here. So if y'all are familiar with Williamsburg, you know how much it's changed. So maybe I'm interested in how much this area has changed in the past, I don't know, couple of years. So whenever we generate the profile, what we get here is you see here multiple tabs. So what this does is it organizes all of the aggregated Census and American Community Survey data into different topic tabs. So the very first view here, age and sex, what we're seeing here is the aggregated American Community Survey data of all of these census tracts. So that's huge because actually when we include the reliability data, if y'all are familiar with American Community Survey data, you know that there are things like margins of error. And not all of that data is always reliable. Not always that fun to talk about, but it's really important if you care about the reliability of whatever point you're making. So what we do here is we include all of that reliability information based on a selected area and then the comparison area. So suppose we want to compare this area not with New York City, but instead, let's say Brooklyn, the full borough, we can change our comparison area and get the total population comparison between our study area and Brooklyn. And we can also look at the percentage point difference. So not only are we calculating and showing the two areas, but we're also calculating the difference between those. And we're providing the reliability statistics about that difference. So there's actually a reliability measurement involved whenever you're comparing survey data like this. So this is the demographics section. Here you get two modes for the profile. There's the there's just the spatial comparison, and then there's the change over time comparison. And we can see here that obviously it looks like the study area has remained more or less the same, but if we look into the economic profile, for example, if we're interested in, for example, the labor force, or suppose we want to find something like income and benefits, we can look at median household income in dollars and see whatever comparisons we can find or whatever we're interested in for the study area. So we also have a lot of data here, including housing information. And if you scroll down, you can see all of this great American Community Survey information. Other features we have are, copy table to clipboard. So what this actually does, if you're an Excel user, we all have used Excel. I mean, Excel's fine. I like it. You can copy the table to clipboard, and guess what? It will save all of this styling information, which is really nice. There is also an ability to download the data. So you can download this view of the data if you would like. And also, if we want to go ahead and change our selection again, we can refine this a little bit. Say I want to remove, this and go back. I went ahead and made another profile. So if you actually look here in the URL, I can share this, with a colleague, and they will see the same exact view of that awesome housing profile for the study area. So again, this is really great because if our planners are working in an area and they want to share whatever they're finding in whatever area they're working with colleagues, they can be on the same page about whatever information they're looking at. So suppose I'm like, oh, hey, Chris, I want to look at the change over time information and I want to show the reliability data. It's going to show them the same exact view, which is really powerful. So that is Population Factfinder. And now I'm going to hand it over to Chris.
Thanks, guys. Okay, so I'm going to look through a couple more applications. This one just launched yesterday. It's called Metro Region Explorer. This is actually sort of a story map format, and we built it in a way that we could reproduce it again for another unit in city planning that wants to sort of basically apply these sort of narrative-driven stories. But essentially, you can click through and learn about sort of a selected subset of features of the New York City region, and even click down into the sub-region or municipality level and get some very interesting data. So I'll leave you to look at that one on your own. We've also done sort of really lightweight, like New York Times-y, flashy data viz things that aren't really a full-on application. So this is a specific set of bar charts that let you explore historical migration trends for New York City. So there's one team at city planning that focuses on population, and this is like a pet data set of somebody there who's been curating it for years. And for us to bring it to life in a way like this was just really awesome because it just makes it that much more shareable, that much more usable, and of course everything is open data and available for download. I want to get back into, in the time we have left, talking about our stack a little bit. Well, yeah, you see these are primarily the components. The apps that you just saw, most of them are Ember applications, and they use CARTO for our spatial backend, and they use Mapbox.gl for rendering, and then we have a couple of other tools in the workflow. So CARTO is basically our instant spatial backend. As you all are familiar, you take a shapefile, you get an instant set of APIs for vector tiles, raster tiles, and SQL APIs, so you can access it and get JSON and CSVs out of it. This is really important to our ability to be able to tinker and move quickly. So we can just drag a shapefile up and just start building the front end. We don't have to worry about infrastructure and standing up new backends and that sort of thing. And all of them are actually sharing the same CARTO instance, which is awesome. Ember is a framework for ambitious web applications. So all the routing and all the layouts and all the templates are all built in Ember, and we've all become proficient with it. But it's basically our go-to framework for these sorts of things. We're also starting to build a bunch of add-ons that work specifically with Mapbox.gl and with the communication with CARTO that has to happen in order to generate the vector tiles that we use. Mapbox.gl is what gets us these really powerful front-end maps. So we have really tight control over symbology. We have really smooth scrolling. We can have the ability to rotate, pan the map, and do 3D like you saw. And it's just been so flexible and so sort of cutting edge to pair vector tiles coming out of CARTO with vector rendering in Mapbox.gl. We've been tinkering with this before the vector tiles were even documented in CARTO, and we've had a lot of success with it over the last 2 years. Finally, I want to mention Maputnik. Maputnik is basically an open source alternative to Mapbox Studio. And what it does is that it allows us to actually have a graphical interface for creating these really, really complex styling objects for Mapbox.gl. And I'm going to show you in a moment how we actually use it. And then Open Map Tiles Server, which is another great open source project, but essentially allows you to take a snippet of OSM data and turn it into an instant vector tile service. And that's what gets us all the base maps you saw on our maps. So all the streets, roads, parks, bodies of water, labels, and all that sort of stuff comes directly from OSM. And last but not least, GeoSearch, which Andy mentioned. We were having some issues with people being able to find very specific wonky New York City addresses in the OpenStreetMap sourced public geocoders. So we said we're going to stand up our own using the official New York City data set for addresses. So that's what we use for that, and I invite you to check it out. So how all these things kind of play together is we have our applications talking to CARTO either directly or through Node.js APIs that we build on our own. We love conjuring up and deploying Node APIs. They're just really easy to come up with and just put them in the cloud very quickly. We get our Open Map Tile server, we use GeoSearch, and then we use a few different third-party services and sort of bring everything together. So it's very flexible. As long as there's an API, we can consume it, but we use Doit's raster imagery for the historical base maps or historical aerials, and we also use Cyclomedia for that street view that you saw. Okay, so ready for some live coding. All right, so what you see here is an empty HTML document that just says, oh, hi. We're going to put a Mapbox.gl map in it. We're going to talk to CARTO and get a vector tile, and then we're going to style that vector tile. Ready? All right. I got 8 minutes, so let's see if we can do this. OK, so the very first step, so I've got just a single HTML page here. Let's make this bigger so you guys can see. What we're going to do is instantiate a new Mapbox.gl map. So I'm just going to start uncommenting code here. Let's recomment you. Thank you. OK, so what you'll notice here, this kind of looks like Leaflet if you ever mess with Leaflet. It's sort of, const map equals new map. What's different here is that we're actually using, if you look at the style property here, this is a URL to a style that we're hosting on our GitHub account, which basically has all the instructions to use the Open Map Tile server. So what this means is normally what you'd see in a lot of these examples is you need a Mapbox API key, and you're going to be basically pulling vector tiles from their service. We're basically pulling them from our own self-hosted base map vector tiles, and that's what this style object is. And then we set the initial zoom, we set the initial center, and we add a little control. So this should get us a nice little full-screen map. And it still says, oh, hi. And there we go. All right, so this is the Open Map Tiles vector tiles. This is actually the positron style, which is open source and made by Stamen and facilitated by CARTO. Is that right? I think that's right. OK, so you zoom in and you get, it's going to go back and get more vector tiles, and building footprints will appear and all that sort of stuff. So this is just great. It's OpenStreetMap, through all these various different open source components, live on our map, and we don't have to pay a dime for it, which is awesome. And we just thank the open source community for that. OK, so the very next step is to manually instantiate CartoDB vector tiles. So let's uncomment this, and then let's recomment all the stuff that happens afterwards. Just ignore that. Pretend you didn't see it. OK. So same way Maps API works for raster tiles, it also works for vector tiles. And it takes the exact same config. The only thing that's missing is CARTO CSS because we don't want the server to style anything. We just want the data back. So it's the exact same process. So this is the same object that you could send on your own, or that CARTO's JavaScript library would send. But you can see what we've done here. We've made a layer array, and inside that layer array is a layer called subway routes. And what we're doing here is we're just going to do a SQL query that selects all of the subway routes from our subway routes table. And this should get us a data set. What it's actually going to get us back is what's called a layer group ID. And from this layer group ID, we can build a vector tile template and tell Mapbox.gl to use it. So just to prove that it's working, I'm going to reload. And you can see in the console, it said we're instantiating tiles, and here's our layer group ID. So CARTO has now said, OK, I pulled your data out of the database. I am ready to serve vector tiles and raster tiles for that query. Here's the layer group ID you need to request your tiles. So they still don't have them on the map, but let's go another step further. So with Mapbox.gl, once we have this layer group ID, we basically need to add what's called a source. So it's a little different than Leaflet, but vector tiles basically behave as a source that's got a type of vector, and then you pass it a URL, and we're basically building a tile template. The only big difference here is that instead of it being a PNG, it's an MVT. So if you change that file extension, CARTO, instead of serving you a raster image, will actually serve you a vector tile. So if I run this, we still aren't going to see anything on the map because we haven't added it. But if I say map.getStyle.sources, you will see that I now have two sources on my map. One is Open Map Tiles, which is actually rendering all the base maps and stuff right now. And the other one is called Subway, which I just requested from CARTO. And now we have it in the map ready to be styled. So the very last step is going to be let's get rid of that. We don't need that. This map.addLayer. So addLayer basically says this is what I want to draw on the map. You can't just say I want to draw it like this. You have to reference the data that it's going to draw. So we're referencing a source of Subway, which is the source. And we're referencing the source layer subway-routes. And this should get us some lines on the map. And there they are. But they're all black. So how do we style this? So enter Maputnik. So if I mentioned before we use a great open source graphical style editor called Maputnik. So we've actually built a little web server, a little development server that we run. I'm not going to get into what this is actually doing, but if I run this command in the console, it's going to, just like we did for the print service, it's going to pull the entire Mapbox.gl style as a JSON object out of the map in development right now and send it over to another service, which is running Maputnik dev server locally on my machine so that I can style it. So it just pulled the map as it exists right out of my development environment into this GUI so that I can come here and say, for example, these are very thin lines. They look great thin when you're zoomed out, but when I zoom in, I want them to get fatter. So I'm going to click on subway line, and then when I get down into the width, I can actually say, make this data-driven. So I'm going to say at zoom level 15, I want it to be width 5. And at zoom level 10, I want it to be width 1. So now it's at width 1, and when I zoom in, the lines get fatter. And let's say we want to make this at like an 8. So we can tinker around with it. And then down here, what we have is JSON for the actual style. So this is actually how we work when we build these apps. We come into this environment, we tinker with the style, we copy the JSON, we bring it back to the code base and paste it in, and then we're good to go. So I'm going to take this line width object and paste it back in. Actually, I'm going to take the whole paint object. Let's go back to our code and put it right in here as paint. And let's go back and look at our app. And when I zoom in, my lines get fat, and when I zoom out, they're skinny, and that's why Mapbox.gl is awesome. Okay, and then we're just going to the very last step. I have a nice little line color property, and this is how you do sort of data-driven styling. So I'm just going to paste it right in. Where are we? Where'd I go? Where'd I go? And we'll say, not only do we want the line width property, we want the line color property to be dependent on something in the data. And if you look back at my SQL query, you'll see that I not only did I get the geometry, but I got this RT underscore symbol from CARTO. So it's in there waiting to be used to style. So this will get me a beautiful, very nice styled NYC subway map. So thank you for bearing with me through all of that. It's really exciting. We love basically putting together all these open source widgets to make really powerful and useful apps inside of city government. Everything we do is on GitHub. Like we said, we're open by default. There's a 90 up there. There's 90 public repositories, up from 0 when I started at city planning 2 years ago. And it's only going to get bigger. So by all means, check out our apps. And if you want to participate, contribute code, ask questions, we'd be happy to have you. And thank you so much.